All right, let's go through one at least here, step by step, and then we'll cut to the chase and use our calculators to help us out. But just to kind of get the feel of what's going on here. So we've got, usually most of our functions in polar coordinates are, r is function of theta. That's typically what we're graphing or what we're, it's not always the case, but usually we put r in terms of theta. So r is a function of theta. So what that means is, you know, if you think about like a table here, the values we choose typically would be the theta values, and then to plug in to get the r values out of that. And here's what you just kind of want to move your way around the graph, and so, you know, technically you can start at in negative theta range, but we're going to start here at 0 since we're doing it by hand. The calculator's real fast at this, so we can do all kinds of things with that, but let's start at theta equals 0, and then we'll work our way around. I think I had pi over 6, pi over 4, the basic ones, pi over 3, pi over 2. So that one's easy. Theta is 0, so that would be 2 times 1, right? 2 times pi over 6. Cosine of pi over 6 would be the square root of 3 over 2, so 2 times square root of 3 over 2 over 2. Yeah, the square root of 3. Anyway, you could pi over 4, so that's square root of 2 over 2. Remember that? Cosine of pi over 4 is square root of 2 over 2. So 2 times square root of 2 over 2, that's going to be square root of 2, about 1.4. Pi over 3, you got 2 times cosine of pi over 3, which is a half, so that's, you're at 1 there. And pi over 2, cosine is 0. Cosine is 0. And then I did a couple others just to, again, do this kind of by hand. This is how it works. So 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. You can figure all these out, but this is going to be -1, negative square root of 2, negative square root of 3, and back to negative 2 there. Well, so you kind of get the idea. You're just plotting, picking out values of theta, just kind of sweeping your way and seeing what the r's are doing. Well, putting those together, all right, so we've got theta is 0, r is 2. So where's theta 0? It's in reference to this, so theta 0 is right here, isn't it? And I'm going to go out to 2. So that point's there. Pi over 6, so I've got a 30 degree, and then it's square root of 3, which that's about, it's about 1.7, isn't it? Square root of 2 is 1.4, which I don't know. But, so pi over 6, I'm at 1.7. So, you know, think about, you know, there's polar graphing paper, which is kind of concentric circles. Is what that amounts to. So you kind of get, all right, so 1.7 at pi over 6. Right about there. Pi over 4, which is 45 degrees. It's 1.4. Put it about there. Pi over 3, which is 60. We're at 1, which is 1 unit. And then pi over 2, which is 90, I'm at 0, so that's at the origin. 2 pi over 3, well, what happens there is, all right, so I'm going 2/3 of a pi, so say right about there. But it's r is -1, so it goes back down here, doesn't it? It goes back on the other side of the origin. 3 pi over 4, so it's 3/4 pi, somewhere like that. It's negative square, so that's back to the negative 1.4. So again, we're back over here. Along that. And then 5 pi over 6. Yeah, it's almost pi, but not quite, it's 0.7. And then at pi, so at pi, which is this angle, I'm at -2. So I go back 2, so I'm back here. So I've completed the circle here, you see? Kind of interesting. It is supposed to be a circle, by the way. Okay. So that's by hand, and it can be quite monotonous. The good news is, yeah, we'll use, we're going to use, because our goal really is to get to some calculus on this stuff. We can use the TIs here. If you change the mode, you know, we had parametric mode. There's also a polar mode. So go to the mode screen there and change it from whatever it is to polar. POL is what mine says. And then if you go to the graphing screen, yeah, you can put in all sorts of polar graphs. This one, 2 cosine theta. And again, on the TIs anyway, the X button becomes theta when you put it in polar coordinates. So you just have to hit the X button on mine anyway, TIE4. We can do these all day long because, yeah, we can just graph them. Now, one word here, what mine shows up is, it doesn't show up as a circle, kind of more like an egg. But that's because this is 1, 2, and then so it's right, yeah. So this is 1 here. So this, the reason it's not a circle is because these aren't squared up. This unit is a little bit narrower than, this unit is wider than that one unit, you see. So if you wanted to get it a true squared up version, you can change the window to, or the zoom to Z square or something like that, and it comes out more circular. And it does show, it still does show the X and Y axis on mine anyway. Anyway, now, so yeah, graphing by hand, kind of long and tedious, but these can do it almost instantaneously. So let's just look at a couple of them. Some of them are, we'll give names to. R equals 1 plus sine theta. So if I put that in, let's see what I get there. I said you might want to zoom in a little bit. Yeah, that's too much.
So tube looking thing, kind of.
Yeah, it's kind of a circle, but it's got a little indentation in it there. -5 to 5. Let's see what that does. Pretty good. Almost kind of like a spade, but mushroom or something. Actually, what it's called a cargoid. This shape, similar to this, is a cargoid. Heart. I think that has something to do with cardiac arrest. I guess that's it's kind of a heart shape, but anyway, that's what it's called. Those are called cargoids. All right, here's an interesting one too. All right, R equals cosine 2 theta. R equals cosine 2 theta. Yeah, I need to zoom for sure on that one. It's got 4 little branches on it. I think they're each 1 unit along there, if you will. Supposed to be symmetrical. Interesting little graphs. And you have to kind of watch it to see how the thing progresses. Like it starts here and loops around and then keeps kind of looping around. I think that's the way it goes. But anyway, you wind up with this. And they call these, for whatever reason, they call these roses. This is a 4-leaf rose. Kind of a flower. Interesting there, if you do, so that one's 4-leaf. If you do cosine 3 theta, it has 3 leaves. Yeah. Cosine 4 theta has 8 leaves. So, anyway, kind of interesting. And you can get some that are kind of angled differently. I think if you do sine, what does sine 2 theta? Yeah, sine of 2 theta. That's what I was saying. It's a 4-leaf rose, but it's kind of angled differently here. Those are supposed to be all the same size, by the way. Trying to do too quick, but okay. Yeah, so those, you get some interesting shapes, and we'll look at a couple other ones here. But yeah, a couple other ones. R equals 1, or R equals 3, or R equals just some number. Well, that's just saying the radius is always 3. So you got 1, 2, 3. For whatever angle the R is 3. Isn't that just going to wind up being a circle? Yeah. So R equals 3. That's one thing polar coordinates are good for. It's good for circles because it's a very simple equation. R equals 3. Now, most of them, like I said, are functions of theta. Oh, I've got one more R function of theta, but R equals 3, remind me. Let's look at theta equals 2. All right, so that's saying the angle is 2. The angle is 2. And we can make the angle some pi number, but 2 is just to think a little more. All right, so the angle is fixed in to be 2. Well, again, the angles in radians, these angles that we're using are radians. What's 2 radians look like? How much is 2 radians? Degrees wise. Remember your conversion? It'd be pi, 180 over pi.
360.
So it'd be 360 divided by pi.
Or whatever that is.
Yeah, whatever that is. It's about, I was going to say 112. Yes. 114 point, approximately 114 degrees. So that's your angle. The angle's fixed in to be about 114 degrees. So 90 plus 24. So you got, it's all, so the R can be anything. So it's anything there, or it could be negative R. So you just get, yeah, you just get a line at that angle. And that's one you can't do on the graphing calculator, or mine anyway, because it's a theta equals, not a R equals. The other one I'm going to show you here is this one, because it brings up a point about R equals theta. Punch that one in. This one you might want to zoom out. Okay. Yeah, this is a good one to point out. What you get may be just a limited view of what it actually is. Yeah. So it starts here. Comes around. But that's not even half the picture. If you go to, on the TIs that's on the window, the standard setting is the theta min is 0, and the theta max is 6.28, blah, blah, blah. What is 6.28, blah, blah, blah. That's 2 pi. So the standard min max for theta is 0 to 2 pi. So that's what it's going to show you. This one has much more to it.
It's just a spiral.
It's going to spiral, yes. And so one thing we can do is change that to negative 2 pi to 2 pi and see what that does. Did graph it. Yeah, so it kind of does, it puts more to it, doesn't it? Kind of mirrors what we had. But there's even more to that. If you go change it to negative 4 pi, I don't even know if I can potentially draw it. So what I'm saying is, you know, there may be more to it than 0 to 2 pi. That usually gets a lot of times that'll get the full scope of the graph, because what happens is if we did negative 2 pi to 2 pi on the others, it's just going to loop around the 4-leaf rows again. It'll just do a complete circuit again. So 0 to 2 pi usually gets you, what the graph looks like, but not always is what I'm saying. If we do negative 4 pi, to 4 pi, yeah, this just keeps going around and around. Yeah, it just keeps kind of cycling further and further out, but it keeps going around and around. Okay. So the other thing I was going to do here was, what about polar to Cartesian equations? Polar to Cartesian equations. Well, let's change r equals 2 cosine theta to a Cartesian equation. Well, what does this mean? We want to go from r thetas to x's and y's. And what do we know about x's and y's? Well, on this one in particular, focusing on the cosine, we know that x equals r cosine theta, and so x over r would be cosine theta. Actually, I think that's where we started, but I can substitute that for cosine theta, get r equals 2x over r, right? Because cosine theta is x over r. That still has r in it, but I got rid of the theta. Now, if I multiply by r on both sides, that gets me r squared equals 2x. What do you know about r squared?
X squared plus y squared.
R squared equals x squared plus y squared. Aha. There's a Cartesian equation. And you can see, yeah, that's I believe that is a circle. That's what that turned out to be. All right, what about this one? R equals 1 plus 2R sine theta. R equals 1 plus 2R sine theta. Well, just like over here, let's start by focusing on the sine of theta. What do we know about sine of theta? Back in our conversions,
Y over R.
it was y over r. So that's r equals 1 plus 2r times y over r. So just make that conversion. And in this case, those r's cancel. So it's just r equals 1 plus 2y. So I got rid of one of the r's, but I still have an r. So there's not an r squared that I can substitute for, but I can do the next best thing. What can I do for r? Make it, yeah. Could square both sides. That may be, yeah. Yeah, let's just do it this way. Oh, that's what I did. Well, yeah, it might be a little better if we do square both sides of that maybe. Because that kind of limits it to probably one side, yeah. So let's square both sides, whatever point. Anyway, kind of the idea there. If we go the other way, Cartesian to polar, sort of the same idea. So we've got x squared plus y minus 3 squared equals 9. We've got x squared and it's y. I'm going to have to involve, those same conversions. X squared plus y squared equals r squared. X equals r cosine theta. Y equals r sine theta. I'm going to have to use those, obviously. And so to get those involved here, just go ahead and square this out. So that'll be y squared minus 6y plus 9 if I do that all out. Of course, that and that, those will go away. So I wind up with x squared plus y squared minus 6y equals 0. Yeah, if you've got things in terms of x squared, y squared, and y, we've got those tailor-made, right? X squared plus y squared, that's r squared. 6y, well, y is r sine theta. And what they typically do here, again, we like r as a function of theta. So kind of a move that term over. Here's kind of how they'll do it. Add the 6r sine theta, both sides. It's this. And then if I divide by r, it'll get a nice, those r will cancel. So it gives a nice r function theta.